Algebra 2, this is exponents review that I want to go through. You should have 2 pages to this one that just has the properties on it. And then the other one is a sheet that looks like this that has a whole bunch of problems. And I kind of have circled which ones I kind of want to go through with you. And then some of them I'll have you guys do within the video for, just homework, I guess, or exercises to do. So let's go through these properties. You've seen these all before. I know that you have. But this first one involves a product. Okay, so I go through these two all the time, product and power. People get those confused all the time, and like questions on the ACT, they try to confuse you by putting those two problems right next to each other. So this first one is saying, like, if you have x squared times x cubed, and let's say the second one says x squared in parentheses cubed, okay? Remember, which one do you add, which one do you multiply? So in the top one, you are adding those exponents. That would be x to the 5th power, okay? In the second one, you're going to multiply, so that will be x to the 6th power, because really what this is saying, when you take something to the 3rd power, that means you're taking it times itself 3 times. Okay, so I have x squared, x squared, x squared because I'm doing it 3 times. So that just kind of, proves why it is x to the 6th power and not x to the 5th power. So here is where you multiply when they're like stair-step like that. You add the exponents if there's 2 bases, kind of like that one. Okay, this one is saying that when you have an exponent out here, outside of the parentheses, you distribute the exponent through. So I'm going to say, like, let's say I have x squared y to the 4th power, and I'm taking that to the 3rd. Okay, what I would do is distribute the 3 through, and here I am multiplying. So that would be x to the 6th, y to the 12th. That's what he would look like. Okay. Now, if you ever have a negative exponent, what you can do is you can flip him to the bottom, and he will become positive. So like, let's say I have x to the negative 3rd power. That will be 1 over x to the positive 3rd power. In addition to that, let's say that I have like, x over y to the negative 7th power, okay? I can change that y and make him a positive 7 power if I bump him to the top. So this will just be x times y to the positive 7th power over 1, or really I don't need that 1 on the bottom there as soon as the x or the y goes to the top. So that's kind of how those are interchangeable. If they're on the bottom and they're negative, you can move them to the top. If they're on the top and they're negative, you can move them to the bottom. The zero exponent property, this one that says that anything to the 0 power is equal to 1. So x to the 0 power equals 1. 174 to the 0 power equals 1. Any number to the 0 power or variable to the 0 power is going to be 1. Okay. This one right here says that if I have exponents like that and they have the same base, I can subtract them. So like, let's say I have x to the 5th power over x to the 2nd power. I would subtract the 5 and the 2, and that would be x to the 3rd power. Because really, what will happen, if you want to see how this works, if I move that x squared to the top, okay, this will actually be x to the 5th power and x to the negative 2 power over 1. And 5 and a negative 2, if I add those together, would be x to the 3rd power. So just more verification that that's x to the 3rd power. That's the reason why. If I move him to the top, he becomes a negative 2, and negative 2 and 5 make 3. So that's just kind of how that works, okay? You always want to go in the direction of the bigger number. So like, I'll do a problem up here where, like, let's say I had x to the 7th power here and x to the 3rd power here, okay? In that case, I have like 3 x's on the top and 7 x's on the bottom, so I'll subtract those. 7 minus 3 is 4, but the 4 will be on the bottom, okay? Because I always want to go in the direction of the bigger number, okay? And the last one, power of a quotient, means that, like, let's say I have x squared over y to the 5th, and I want to take that to the 4th power, okay? When they are a quotient like that, I can still distribute that 4 through. So this would become x to the 8th power and y to the 20th power because I'm multiplying those, okay? So that's just kind of a run through of all the rules of exponents. Don't do anything that's illegal, and we'll be all good, okay? So I'm going to go through. I have some circled ones here that I think are particularly important. They're really fast. Number 2, 5 to the negative 2 power and then to the third power. So the negative 2 and 3, am I going to add those or am I going to multiply? Since they're stair-stepped like that, I'm going to multiply those together. So this would be 5 to the negative 6th power. Okay, now I don't want to leave that as 5 to the negative 6th power. I want to change him to be a positive 6, so he will be 1 over 5 to the positive 6th power. Okay, and 5 to the 6th power is a really, really huge number, so I'm just going to leave him like that. You can write him out if you want to, but that's what he will look like to begin with. Okay. All right, now this gets kind of confusing when you have negative exponents and then you also have stuff that you're trying to combine. So if I have a negative exponent, I want to move him to the top to make him a positive exponent. So he will be 2 squared and then 2 to the 9th power on the top, okay? So I have 2 squared times 2 to the 9th power. And in that case, I'm just going to add the exponents. So I have 2 to the 11th power. And then on the bottom, there's nothing left over, so he is over 1. Or I can just leave him as 2 to the 11th power and not put him over 1, because over 1 doesn't really do anything for me, okay? All right, let's go down to like number 9, where I have that 5th power. I wanted to include this problem in here because a lot of people will distribute this through the A and the B, and they'll forget about the 4. The 4 needs taken to the 5th power also, okay? So this will be 4 to the 5th power. A to the, will that be 7 or will that be 10? I'm going to be multiplying those guys, so he will need to be 10, and this will be b to the 15th power, okay? And then let's go ahead and figure out what 4 to the 5th power is. 4 times 4 times 4 times 4 times 4, 5 times 4 to the 5th power. Huge number, 1024. That's not that big of a number, I guess. A to the 10th, b to the 15th. That's what he will look like, all completely done, okay? All right, let's go down to number 13. This is what number 13 looks like. So again, I'm going to distribute that 2. And don't forget to distribute him for the 4 and the A and the 2 and the B. So I have to distribute him 4 times, okay? So the top part, don't get ahead of yourself. Don't try to simplify too many things at once. That will become 4 squared, A to the 6th power, okay? 2 squared on the bottom, b to the 8th power. Okay, and then I just need to simplify my other stuff. So 4 squared is 16, 2 squared is 4, and then what I can do is I can reduce the 16 and the 4. So 16 and 4 becomes 4 and 1 if I divide both of those by 4. So I will have 4 on the top, a to the 6th on the top, 1 b to the 8th on the bottom. Okay. Now, if I had A's on the top and A's on the bottom, I would combine my A's. And same thing with B. If I had a B on the top and a B on the bottom, I would combine my B's. But at this point, I don't, so I can just leave my answer like this. Now, I don't necessarily have to have this 1 here, so if you don't want to put that 1 in front of there, it can just be 4a to the 6th over b to the 8th, and that's how you would leave your answer. Okay? All right, so number 18, we don't have anything that we need to distribute through, so we're just going to reduce stuff. So I start with the numbers. So just do the numbers, do the x's, do the y's, do each one of them individually, okay? So 5 and 20, if I reduce those, both of those are divisible by 5. So 5 divided by 5 is 1. 20 divided by 5 is, 20 divided by 5 is 4. So I have 1 on the top, 4 on the bottom, okay? Simplifying those. All right, now x's, I have 3 on the top and 2 on the bottom, okay? So x's, I will have 1 left over if I subtract those, and it will be on the top. So I can write that as x to the 1st power, okay? All right, now, this is kind of confusing where I have 9 and I have negative 2. So I want to get rid of that negative 2 and make him a positive 2. But to do that, I need to bump him to the top again. So he will be y to the positive 2. So I have y to the 9, y to the positive 2, and I'm going to add those together. So that will be y to the 11th power, okay? And then if I want to rewrite him so that he looks a little bit better, I don't necessarily need this 1 here. I don't necessarily need that 1 there, so I can just say x, y to the 11th power over 4, and leave him like that. Okay, and that's what he will look like. All right. Next one I want to bump down to is 27. This is going to be kind of a short video because these are going to go by fast, maybe. I don't know what we're at for time for right now. All right, so here we are multiplying, okay? And so when we multiply, What I like to do to start with is to reduce any numbers if you can. So just looking at the numbers, 12, 7, 7, and 4, okay? Things that I can reduce, 7 and 7. I can reduce anything that has 1 on the top and 1 on the bottom, okay? So like if I'm multiplying, if I have something here and something here, I can reduce those, okay? If I have something here and something here, I can reduce those. If I have something here and something here, I can reduce those. And if I have something here and something here, I can reduce those. So one of them has to be on the top, one of them has to be on the bottom. The things that I can't reduce, the only two combinations that I can't reduce is if I have something here and something here, or something, I don't know what other symbol I can use, just a dot, something there and something there. So if I have things on the bottom that could look like they can reduce, I can't reduce them. If I have two things that are on the top, I can't reduce them, but I can reduce anything that is across from each other or straight up and down from one another. Okay, so those 7s I can cross out. And then in addition to that, I can do 12 and 4. Dividing both of them by 4, I'll have 3 and 1. Okay, and then what I like to do is, just so that it doesn't get too messy, let's just write out what the top looks like. So on the top, these 7s are both 1s, by the way. So I have 3 times 1, which is just 3, okay? Then x's on the top. How many x's will I have on the top? I have x to the 5th power. That will be x to the 6th, okay? And then I have y and y squared, which is y to the 3rd, okay? On the bottom, I have 1 times 1, which is just 1. I have x to the 4th, and then I have y, okay? And now I can do one more step where I, put the x's and the y's together. So I'll have 3 over 1. That's not going to change. He's done. Okay. But then I have 6 x's on the top and 4 x's on the bottom. So I'll have 2 x's on the top. And then I have 3 y's on the top, 1 y on the bottom. So I'll have 2 y's on the top. Okay. So I have 3x squared y squared all over 1. And I really don't need that 1 on the bottom. So I could just write it as 3x squared y squared and be done with it there. Okay. All right. Last thing. I've got 2 of them on the back side that I want to talk about. So number 13 to start with. 13 is a really quick and easy one. B to the negative 2 power. I kind of talked about him already. I want to make him a positive 2 power. So he needs to be bumped to the top. So this could be written as 1b to the positive 2 power over 1. Okay, because when I move him to the top, there's nothing left over, so we put a 1 there. Or 1b squared over 1 is just b squared. I can write him like that. Instead. Okay, so that's what he will look like, right? And last one, number 18. Aha, this one's a really good one because this is a long one. All right, so let's see if we can do all this stuff, okay? So the only thing that I have to distribute through is this 2 here, okay? So we got to be careful of that 2. I'm going to distribute the 2 here, 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 and then at the bottom I'll have 3 places to distribute him on the bottom. Okay. So let's do this. I'm going to rewrite this top one right up here. Okay, and then I'm going to rewrite what I have left over here. 24x to the 5th, y to the 4th, 3x to the negative 2y. Okay, I'm just rewriting that first piece, and now I'm going to distribute that 2 through. Okay, you could have simplified some stuff in here, like some of you guys noticed that 24 divided by 3 is 8. Okay, I could put the x's together, I could put the y's together. And you can totally do that if you want to do this in a different order. You'll probably get the same answer as we will. But just to keep everything from getting messy, I'm just rewriting everything. So I'm going to distribute the 2 through. So I have 2 to the 2nd power here. 2 to the 2nd power. Okay. I have x to the 2nd power and y to the 4th power. So if I distribute that 2 through, that's what my top will look like. On the bottom, I will have 3 to the 2nd power, x to the 2nd power, y to the 2nd power. Okay, so that's what he will look like on the bottom. Okay, all right, I'm going to get rid of this. I'm going to call that 4 now, and I'm going to call this 9, so that I can fix those numbers at least. All right, and then I want to reduce things if I can reduce them. So let's look at the numbers first, just the numbers. So I have 24, 3, 4, and 9. Okay. So I just kind of said that 24 and 3 can become 8 and 1. So let's go ahead and do that. I can reduce those. Let's see, anything else? I can't reduce the 8 and the 4 together because those are both on the top, so I can't do that. So let's go ahead and write what our bottom looks like now. Okay, or our numbers look like. So I have 8 times 4 is 32. On the bottom, I'll have 1 times 9, which is just 9. Okay. All right, now, rather than crossing out all the x's and crossing out all the y's and getting everything really confused, I'm going to put my x's together. So I have 5 here and I have 2 here, which makes a total of 7 if I put them together. Okay. I have 4 here and 4 here for y's, so I'll have 8 y's on the top. Okay, and then on the bottom, for x's, I have -2 and I have +2 x's. And since we're adding -2 plus 2, well, those guys will just cancel out. So I will have no x's in the bottom, so that's kind of nice. And then for y's, this is y to the first power, really. I have y to the second power, so that'll give me 3 y's on the bottom. Okay. Now the only thing that I have left to put together will be my y's here. So I have 8 on the top and 3 on the bottom, which will give me 5 left over on the top. So I'm going to rewrite 32x to the 7th over 9, but then I have 3 y's left on the top. Okay, or no, 5 y's left on the top, not 3, 5 y's left on the top. Blech. 8 minus 3 is 5. And that's all that I can do for that one. Okay, so don't get too far ahead of yourself. You guys can do these problems. They are not that hard. But the problem that you're going to run into is trying to cancel out too many things at one shot. So if it gets too messy, rewrite it before you end up simplifying anymore, because then it won't be so messy and you won't end up making stupid mistakes. Okay. All right, so review of exponents, that should all be stuff that you've done before. We're going to do radical expressions in the next video, and that's all I have.